Hi, welcome back to the channel. In this lesson, we'll see vector products of vectors. I'll start by explaining the various methods of finding vector products of vectors, after which we'll solve an example. At the end of this lesson, I'll leave with an exercise which you can practice your hands on. That said, let's get into class. Welcome back. Like I did promise, I will explain different methods of finding vector products of vectors. The first method is expansion. If I have a vector A, which is equals to A xi plus A yi plus A zk, and I have another vector B, which is the same thing as B xi plus B yj, sorry, this is A yj, sorry, plus B zk. Now, if I want to perform a cross product or vector products are also known as cross products. I'll say this, then we can expand A xi plus A yj plus A zk. Now cross multiplying A B xi plus B yj plus B zk. In the process, you have your i's multiplying each other, I multiplying j, and the likes. Now this is how to treat it. Now my I, j, and k in vectors, they actually form at 90 degrees to each other. Actually exist at 90 degrees to each other. So that if I have this as I have this as j, and I have this as k. So that in multiplying I times I, the angular difference between I and I is 0. So that I cross multiplying I will be the same thing as 1 times 1 sine 0. And sine 0 is 0, so this is 0. Now, but when you want to multiply I times j, between I and j, there's a 90 degrees. So I times j will be the same thing as 1 times 1 sine 90, which is equals to 1. But now is in the direction of k. So I address this to be equals to k. But there's an easier way to relate to it. I prefer to relate to it using a circle. I'll divide this circle into 3 points. This is I, here is j, here is k. Now, when I'm multiplying I by I, there's no movement. So that I times I obviously equals 0. If I'm multiplying j by j, there's no movement. This is j times j equals to 0. If I'm multiplying k, k will be k times k equals 0. Now, but when I'm multiplying I times j, I'll be moving in the direction of the clock. So it's going to be positive. So that I times j now will be the same thing as k. It's moving direction of k, and it's going to be positive. I now times j now times k, multiplying j times k, I'm moving towards I, that will be equals to I. And when I'm multiplying k times I, still in the same direction, it will be k times I, that will be the same thing as j. But the reverse is the case when I begin to multiply in the other direction. So that if I'm multiplying I now times k, I times k, I'm moving anti-clockwisely. I'll be moving towards j, but in the other direction, that will be minus j. And when I'm multiplying k times j, it will be k times j, be I, but it will be minus I. And when I'm multiplying j times I, it will be in the other direction, j times I, that will be minus k. Now you can see the unique difference, and when expanding, you begin to apply each of these. But things can become easier. We'll see a second method, which is the determinant method. Let's see it. Using the determinant method, if I have two vectors, A and B, all I need to do cross product multiplication is to find the determinant. Here I have I, J, here I have K. Here will be AX, AY, AZ, and here will be BX, BY, and BZ. Now find the determinant of this 3 by 3 matrix so that my cross product A times B will come from I into. Now when looking for determinant of a 3 by 3 matrix, I'll break them into minors and cofactors so that this will be positive, here will be negative, here will be positive. So that I'll pick the elements out of this matrix so that here I'll be left with AY, AZ, BY, BZ. Next, I'll be picking J. If I pick J, then I'll pick every element out of this line. That I'll have minus J into AX, BX, AZ, and BZ. And lastly, I'll be picking K. So that when I'm picking K, we'll cross this out. Then we can pick every other element. We can pick every other element here. So that I now have plus K into AX, AY, BX, BY. Now this is quite easier than the first method. Let's apply this in solving a question. Our question says we should find the vector product of vectors A and B, where 3i minus 4j plus 4k and b is equals to 2i plus 5j minus k. We'll be saying that A times B using the determinant method, I'll have I, j, and k. Here will be 3 minus 4, here is 2, here will be 2, 5, here will be minus 1. So that this is the same thing as we have I. Now forming the 2 by 2 matrix like we did earlier, here will be minus 4, 2, 5, minus 1. I've only picked elements that do not fall within the rows and column associated with I. Then minus j now. Here will be 3, 2, 2, minus 1. Then plus k. Here will be 3, minus 4, 2, and 5. Yes, plus k. Now to help you understand how to find determinant of a 2 by 2 or a 3 by 3 matrix, we'll place description to our lesson on determinant of matrices. So that A times B now will be the same thing as I into minus 4 times minus 1, that's 4, minus 10, minus j into 3 times minus 1, that's minus 3, minus 4, plus k now into 3 times 5, that's 15, and 3 times 2 times 4, that's minus 8. Minus 8. Okay, that's minus 8. Sorry, that's minus 8. So that A times B will be the same thing as 4 minus 10, that's minus 6i, minus 3 minus 4, that's minus 7, times minus 1, that's plus 7, plus 7j, and 15 minus minus 8, that's plus 23, that's plus 23k. That's plus 23k. You can see this is a lot easier than the expansion method. Here is an example. You can practice on this. Our next lesson will focus on solving this example. And to ensure you get our next lesson, please do not hesitate to hit the subscribe button.